Hello and welcome to this month's NEIMME lecture, given by Graham Nicholas from the A1 Locomotive Trust. A quick reminder of last month's lecture. This was held jointly with the Institute on Corrosion on fire coating protection. Good attendance, lots of views, excellent questions, especially from those joining us from the Institute of Corrosion. Vote of thanks, David Mobbs, and the closing remarks by Steve Martin. Our next lecture is given by Dr. Charlotte Adams of the Coal Authority on the subsurface aspects of the Gateshead Mine Water Heat Scheme, and we hope you'll join us then. If you want to find out more about all of our events, just follow us online. We have lots of exciting things on, from the lectures that you're attending today, as well as regional leading conferences, our annual dinner and symposium, CPD and monthly socials, as well as field trips as well. Don't forget, the best way to support our work is through membership, and there's plenty of excellent membership benefits on offer. To find out more, just visit mineinstitute.org.uk/membership, and you can get a membership form downloaded from there as well. And now on to tonight's lecture, and I'll hand you back to Steve in Newcastle.
Right, so I think we've been through the NEIMME paperwork, so it only leaves me now to present Graham Nicholas, who's going to give us a talk tonight on he's from the A1 Steam Locomotive Trust. He's going to give us a talk on the new Prince of Wales and its new designs, and I'm sure you can't wait for it to happen. You don't want to listen to me, but what I will say is Graham's responsible for engineering quality, tied in close to a certification process for the locomotive with the Trust's NOBO as a professional railway engineer, currently working for railway approvals, English, Welsh and Scottish, as a vehicle acceptance engineer. For example, for the approval of the new Class 66 locomotives entering the UK. Graham is well placed to meet the particular challenge of certifying a brand new steam locomotive for UK mainline use. I can't wait to hear this. Graham's a professional railway engineer of over 30 years standing, first joining British Rail as an engineering management trainee in 1986, not so long ago. Wow. Yeah. Having spent the formative years in his career in rail vehicle maintenance depots in the northwest of England. He is latterly specialised in rail vehicle certification and approvals, and is today regarded as one of the country's leading experts in these processes, having written and updated the RSSB industry standards in the area. Graham first gained his registration as a chartered engineer in 1991, and in 2014 was elected as Fellow of the Institution of Mechanical Engineers. So that's enough from me. I'm going to leave it now to you, Graham, and here we go.
No, okay, right. Well, good evening, ladies and gentlemen. It's both a privilege and a pleasure to be able to give this presentation to you on behalf of the A1 Steam Locomotive Trust. So, all being well, we'll start with a piece of video.
This amazing, huge steam locomotive is the latest incarnation of a class that's long gone, known as the P2s. They were designed specifically for the really arduous route from Edinburgh to Aberdeen by the famous London North Eastern Railway Chief Mechanical Engineer, Sir Nigel Gresley. So what they wanted was an engine that could put maximum power onto the rails, and the obvious solution was to have 4 axles, i.e. 8 driving wheels, rather than 3 and 6 you get with the Pacific. Our objective is to restore the glory days of the P2 class. What we've done is taken the opportunity to put right those problems that the original had.
We're in the middle of piping up the locomotive for steam, water, electricity and other fluids as required around the engine. This is inevitably a fairly long stage which takes a lot of man hours and doesn't actually produce much visual effect. We are between 2/3 and 3/4 of the way through. We have for some time now had an apprentice machinist here who got to a stage where he can make all sorts of parts for us, and throughout the project we've been manufacturing fittings so that when we get to the end they're on the shelf and we can put them on quickly.
We estimate it's about a £5.5 million project. We've currently raised about £4 million. We have a regular supply of income coming in from our fantastic covenanters and supporters, but I need to accelerate that income rate. It would be an absolute tragedy if this locomotive does not play a central role in Stockton and Darlington 200, the bicentenary of Stockton and Darlington, which will take place in 2025. We've invested so much time, energy, effort and sheer emotion into this. So what I could do with is more people to come on board, people who are proud to be British and proud of what we are trying to achieve here with this utterly amazing engineering asset. It is the ultimate steam locomotive.
Okay, well, any questions then? No. That was obviously just a promotional video. We update those every few years. So, as it says, here's one we built earlier. We do have a track record. You may well already be aware of this locomotive, the 50th Peppercorn A1 Pacific, number 60163 Tornado, which sort of put us on the map, as it were. Entered service in 2009. It's run in excess already of 100,000 miles on the GB mainline railway, so it's not exactly new anymore. It's travelled to all four corners of the country, featured on Top Gear, hauled the Royal Train 3 times, and achieved 100 miles an hour in 2017. Sorry, oh dear, that's it. I do beg your pardon. Right, press the right button, Graham. Okay, so the new project. We have a mission statement to develop, build and operate and improve Gresley Class P2 Mikado steam locomotive for mainline in preserve use. And it's the develop bit that's quite interesting there. That's the extra sort of verb there, if you like, compared to the mission statement for Tornado. That's the challenge we've set ourselves, to go like one stage further after Tornado. So there is the original. That is number 2001, Cock of the North, as emerged from Doncaster works at the very end of May 1934. It was to some in a lot of ways it was an experimental locomotive. It was built for a specific purpose, but there was quite a lot of experimentation built into it, some of which are listed there. It's the first locomotive the LNER produced with a 50-foot square firebox grate, which they were getting bigger and bigger. First use of the kill chap chimney and blast pipe arrangement, which was so successful latterly with the Gresley Pacifics, and various other things there. The most notable feature, though, is the Lentz rotary cam poppet valve gear, which we'll talk about a little bit later. So quite different from normal slide valve, or rather piston valve and Walschaerts valve gear. Quite a radical departure and a bold sort of initiative. As soon as it was built, it went on test, obviously. It was a new locomotive. So on the top left there, it ran with an indicator shelter fitted at the front, and literally 2 engineers sat at the front there, protected by that shelter, while the thing bowled along, trying to keep an eye on various dials and things, which probably wouldn't allow that sort of thing now. Gresley was great friends with the famous French steam locomotive engineer, André Chapelon, and it was readily agreed to take the locomotive over to the new test plant at Vitry near Paris. It was one of the first locomotives that was tested there, so they attempted to do some tests partly successfully. with it in November 1934. But it became a celebrity locomotive as well. Great, it was a pin-up boy, or should I say a pin-up girl, for the LNER. So you can see a picture there on the left-hand side with the world-famous Flying Scotsman locomotive, the two locos together. A scene we might be able to reproduce in a few years' time. Literally a couple of days after it was first out of Doncaster Works, and a boys' magazine, Modern Wonder. There you go, on the right-hand side there, sort of showing the details of the loco. So certainly quite something when it first came out. However, the war intervened. Gresley died in office, and his successor, was having none of this sort of, small class for individual. He was all for standardisation. So it was kind of a dream that was never fulfilled in a way. The loco, that is the same locomotive, believe it or not, rebuilt into Pacific form, and it sort of ended its days in largely sort of ignominious at the end of the 1950s. So basically, they haven't been seen in this country since the middle of the wartime. The last ones were rebuilt during the wartime, so it's 80 years plus. There's very few people around who can sort of remember them as original locomotives. So it fills another gap in preserved steam. But what we really want to do is realise the potential of the original design, because it never was perfected. They just didn't have the chance to do so at the time. So that is the bit about developing it, so it will actually achieve what it was set out to do. It's quite handy for the modern main line for charter trains, because it's all about, the 13th or 14th coach at the end of the train is the one that actually makes the difference between profit and loss. So to haul big trains is actually essential from an economic point of view. And the procession to the plinth continues. This year is the 100th anniversary of dear old Flying Scotsman. How much longer it can keep going, although there's not much of it back from 1923 left on it. And we had a lot of fun building Tornado, so we try and keep the same team together. We said £5 million originally. That's now £5.5 million between you and me. I suspect it'll be £6 million by the time it's finished. It's a lot of money to raise as a small charitable organisation. We don't qualify for Heritage Lottery money because we're building a new one rather than preserving an old one. So we have to raise it other ways. However, we have had a track record of raising money. Tornado cost £3 million to build, and there's more money raised since to keep it going. And other heritage projects mentioned there have also raised similar sums and more. And on the right-hand side there's some of the ways the money's raised. Regular donations by Covenant is the most popular and successful way of raising money, and there are dedicated clubs for the major components if you want to sort of more associate with a particular part of the locomotive. And then lastly, sadly, but in a way nice in people's memory, legacies do come along every now and then, which we can put to good use, obviously. And there are types of grant money that can be applied for. So that's a large part of the project, and I tend to sort of put an emphasis on that. It's not just about the engineering. The engineering can only take place if you've got the money. So covenanting, when Tornado was built, we used to say an A1 for the price of a pint. The price of a pint of beer in the northeast of England in the 1990s has been about £1.25. I think it's gone up a bit since, so we're now saying £10 a month. With gift aid, that's worth £12.50, and we've now passed over a magic 1,000 covenanters signed up, and you can do the maths there to work out how much of a guaranteed income stream that gives you each year. So that is still the bedrock of the fundraising. We do have some elements of commercial sponsorship. We always like to give a word for our sponsors. So there they are there. A couple in particular, Darlington Borough Council, have been great sort of supporters and friends of the Trust, because it's a good news story for them in the local area. So we always give them a special mention. And also William Cook Cast Products, who says nothing's ever made in Britain anymore. Stoutly British firm, still in heavy engineering. Their chairman has also been a fond supporter and friend of the Trust, as well as some of the other companies you name there. And that slide's a bit out of date, because we usually put up the name of whoever's running the East Coast Mainline franchise this week. which of course is back in national hands. So on to the engineering then. I'm sure the bit that'll be interest you. With Tornado, we kind of built it a lot off the original drawings, and we used a bit of 2D design work, but computing power has moved on, and because so much has to be redesigned, we've made extensive use of 3D CAD in the design work. The whole loco is there in 3D CAD, and we can drill down to individual nuts and bolts literally on it, which is a tremendous asset. And also from 3D CAD, you can then produce accurate drawings, and you can even sort of send the machining files to the computer control milling machines, and everything comes out absolutely perfect, which you didn't with Tornado, but this thing just arrives like a Mikado set, and you just bolt it together. So it's a big change in the way and the approach there. There is, believe it or not, there is quite a bit of commonality with Tornado. Those are the items in green. We can use the same patterns and drawings for some of those, but the rest have got various stages of redesign, and that's indicated on the drawing, as you can see there. So the principal areas of redesign, there's about 5 I'm going to tell you about. The first is an improved pony truck and frame design. That's the leading set of wheels that guide the loco along the track. I'll tell you sort of the reason for the redesign of that in a moment. Then there's the work on the valve gear arrangement, the poppet valves, to try and optimise those because there were limitations with the original ones. Investigate and reduce the risk of crank axle failures apparent in the original design. Network rail don't tend to like it when wheels fall apart. That's a bit of a no-no, that, so we need to sort that out. Investigate and confirm design and method of construction of cylinders to go with the valves, and the comprehensive electrical power supply system. Although it's a steam locomotive, it's ever power hungry for electricity, as you'll see. So the first thing was the ride feasibility study. In fact, we did this before we started building it. This was kind of we wanted to do this before pressing the go button in case this turned out to be a complete red flag. The original P2s had an adverse reputation, and it's alleged that's the reason why they were built into 462s. Basically, the more fixed wheels you've got, the more difficult it is to go around corners, fairly straightforward, and they had a reputation for track spread and derailment. When we actually looked into it, there was very little evidence of that. I think it was more myth than sort of a fact. We basically could find sort of no evidence, but we had to win confidence of the industry. So we applied a little bit of modern technology. So that's the existing, that was the original design of the pony truck, and it works on a swing link arrangement. As it translates to one side, the swing links attempt to lift up the engine above it, and that gives a centering, restoring force. But it wasn't believed ever to be particularly optimal. So the idea was to model that in a computer way as the original, and then compare it with the alternative design and prove that it improves the ride. And that registered mark Vampire, maybe just a quick explanation, that's the rail industry's recognised computer modelling system for evaluating ride performance of vehicles. All new vehicles go through that before they go out onto the tracks. In the old days, you could run them, and if they fell off, well, you sort of improve the design. You can't really do that anymore. You have to prove it that it'll work first. So we've done a Vampire study on the loco, which in itself was quite, sort of groundbreaking. Hadn't been done before. People thought it wasn't possible. And that's what we've come up with. This is the design for the side control spring. So there's a centering spring in the middle, you can see there. So in a way, it's fairly straightforward technically. This spring here, as soon as it moves to one side, that translates either way and puts a restoring force. It's about a 4-ton preload on that, and will obviously increase as it goes to one side. The one slight issue was because the loco is so long, it has to translate a bit further. So although it's based on existing design, we've had to modify it slightly. But the computer modelling predicted that would ride better than the originals, and it would give a ride performance similar or better to Tornado, because once you've got the reference case, then you can use that as the basis to say it's going to be okay. So here it is under construction. The central main frame there, and then there's the steering arm behind. They're all being sort of machined. And then the one on the right-hand side here, this is the sort of center pin and the translation arrangement. There's two sort of arms go through there. The springs are either side. But that's all been done, and it is installed. Well, it's installed for photographic purposes inside the locomotive. I don't think the springs are actually fitted yet, but basically that's tick in the box for that one, all being well. So, next problem, the crank axle. We kind of knew a bit about this. More in-depth research showed there were actually 5 known examples where the class broke its crank axle during a period of operation of, in fact, less than 10 years. And perhaps I just should explain what I mean, or what the crank axle does. All 3 cylinders of the locomotive, the 2 outside and the middle one, all drive onto the same axle. So all the load goes through that one axle, so it does do a lot of the work. It was the same design as on the Gresley specific locomotives, but it didn't tend to cause so much of a problem, and they generally ran about 250,000 miles, 250,000 miles, until such point as they changed them out. I mean, they did get fractures on those, and they eventually settled on very empirical, 250,000 miles. The problem was the P2s broke their crank axles before they got to 250,000 miles, so clearly it wasn't up to the job. Quite sort of logically, if you've got more driving wheels, less carrying wheels, it's not going to slip. Once you put too much power in, the wheels spin, then it obviously dissipates the energy. It doesn't do that so much on a P2 because the thing's so sort of powerful, and it's got higher piston forces anyway. So that required a bit of redesign, but remarkably, we came across this piece of proof. This was a complete fluke. We were talking to a sort of non-destructive engineer, and he had this sort of, like they do, a black book of all these sort of things that are broken, and this was his picture he unearthed from July 1939, and it is a P2 class locomotive. Now, for those who are into the metallurgy, we'll kind of recognise this as the classic waves of a crack starting. Gets about 2/3 of the way, and then bang, the rest went. And it all started here. This is a keyway that keeps the wheel on the axle. And it was not a particularly refined design. They had no way of detecting these in the day, and there it went. After about 2 years and 11 months of being fitted, after 133,000 miles, so barely half of the target, it attempted to set off from Stonehaven Station on the northeast coast of Scotland with a heavy train, and there was a bit of a bang and a lurch, and that was the driver's day up, as it were. So that evidence if we needed it, but that was quite useful for the redesign work. So we gave it to one of the engineering consultancies in the rail industry that know all about this, and they use the current British design standard for axle design and axle wheel interface, available to have a stronger axle material that can be used. The wheel and bearing seats increased by 3/8 inch diameter because we're fitting roller bearings to these, so that matched a known roller bearing size, and we also can make the crank legs out of a stronger steel as well. So all in all, it's quite a bit you can do. So that's just gives an example of the sort of study going on there. On the left is the original design, on the right is the new design. Don't look that different, but it's the devil's in the detail, shall we say. And the next picture, I think, there shows you more elegantly what's going on there, as well as the thicker or the greater diameter of components. 2 things to note here. This is what is now, or they call a stress relieving groove. That's where the wheel actually sits on the axle. If you don't have that, it frets away at the actual corner, but it actually overlaps the stress relieving groove, and that prevents the that effect happening. And then this is the keyway. It's still there, but it's got a sloping, and it stops short to the back of the wheel, and that will reduce or prevent the initiation of the crack that we saw on the original. So here it is, being manufactured at an industry-approved wheel set assembler at the South Devon Railway, and they've obviously 5 pieces of metal there to get them lined up perfectly, but they knew how to do it, and they can see on the right-hand side they're looking quite proud of themselves. There it is, back at the Darlington Locomotive Works. On the left-hand side has arrived and painted. The right-hand side, you can see the roller bearing axle boxes fitted there. So that's hopefully done, as it were. And then on to the valve gear, which is probably as interesting and challenging an area as we've had. So as I say, the original number 2001 was first equipped with lens rotary cam poppet valve gear, and it was designed for a continuously variable cut-off, so the driver could alter the proportion of time the steam's being admitted into the cylinders for maximum efficiency of working. But the trouble with that was that sort of metallurgy at those days weren't as advanced as it was now, and there was a lot of premature wear on the cam followers, and it just couldn't get the reliability out of it. So they modified it to a rather crude stepped cams arrangement, whereby it suddenly went from 18% cut off to 25% cut off, and that's a very crude step up, as it were, or step down, which meant that they used more steam than necessary. Reduction in economy. So, and it was never really resolved. What actually happened with the original was they got rid of the Lentz valve gear and they put conventional Walshart's valve gear on, so they effectively gave up after about 2 years. However, it wasn't the end of the Lentz valve gear. It was picked up by other railways around the world, and this is an example of a locomotive that ran in the USA after the war with the modified version of the valve gear fitted by the Franklin Locomotive Company in USA, and it ran for about 16 years quite successfully, although it wasn't replicated on a class wide front, but nevertheless it was a proven application of the design. And rather remarkably, one of the sons of the Franklin Locomotive Company engineers in his loft found some rolled up drawings which had the complete set of valve gear arrangements. So David Elliott, who tends to sort of unearth these things, managed to get hold of them, and they were sent across the Atlantic, and there he is studying them for the first time. So that obviously gave us a great help with the work. Meanwhile, the cylinders and valves go together. So we're taking the two sort of things very much together here. The original design, as you can see there, this is a cross section, and it has inlet and exhaust valve ports associated with each cylinder. But whereas they're together there on the outside cylinders, they're either side on the inside cylinders. And although it's difficult to see, I can't really show you on that two-dimensional drawing, it leads to excessive clearance volume on the inside cylinders. So there's more sort of steam piled up there on the inside cylinders waiting to come into the cylinder, or rather the distance between the valves and the cylinders, sorry, than on the outside. And that leads to an imbalance and also a waste of steam energy, which leads to a clearance volumes of up to 16%, which is actually quite wasteful. So that was also known to be something worth redesigning. And back to the 3D CAD again. In fact, we've actually got even better. So we gave this to a enthusiastic volunteer who turned this into a sort of an artistic image of the new cylinder design. So this is the arrangement now that's been decided upon, with the two valve inlets in the same configuration as the outside cylinder to even out the clearance volumes. But there's a but. The problem with that is that the drive to get to that one in the middle there, because the drive, it's three each side, if you like. So to get to that one there, there's this cam arrangement going to be installed to actually actuate that particular valve off this side of the locomotive. So that's, it's this trade-off, isn't it? Always with engineering, you try and solve one problem and another crops up. But that is how it's going to be. Again, a useful cross-section through the 3D drawing there. Because this was all getting a bit complicated, and the fact that the cylinder block, I should have said, the original was a one-piece casting, which you can imagine that was a rare old thing to make. And to make that as a one-off is, well, would be very expensive, because the pattern and the arrangement of the pattern would be tremendous. Plus the ability to cast it first time without shifting or whatever. So anyway, a decision was made that this was going to be a fabricated cylinder block, as has happened in more modern times, certainly in other countries. They're quite familiar with fabrications. So it was designed as a fabricated assembly, quite a complicated fabricated assembly. So David Elliott bought himself this 3D printing machine, and he's actually making a 1/10 scale model of the cylinder block design to show to potential manufacturers, just to give them an idea of what's required. So it's a mixture of plates and castings to make the whole thing up. So the contract was given to Howco Engineering at Irvine on the Clyde coast, in the outskirts of Glasgow. They're more used to doing sort of offshore marine heavy-duty engineering, but it was otherwise something they thought they could take on. So there are some pictures of the thing under construction. They do the 3 cylinders separately, then the whole thing comes together. You might just be able to see there on the top here, there's the 10th scale model sitting on top of the actual inside cylinder. And Howco did say that model was extremely useful to them because it came apart and they could see how to get the weld sequence right to get the thing done. And this is sort of the latest news. It was unveiled at the 2022 convention, so just a couple of months ago. It was actually brought back from Howco slightly prematurely, but just to coincide with the convention. We always like to give the Covenanters something exciting to see for the first time. The covers came off and they were the first to see it before it went to the press. So there it is, a rather impressive lump. I think it's about 4 tons in total it weighs. But there's only one person who can explain it to any great extent, and it's the inevitable and irrepressible Mr. Elliott. So I'm going to give my voice a rest for a moment. I'm going to let him talk. Now this is, in total, it's about 15 minutes, this video. In the interest of time, I'm just going to take a couple of segments to show you of the most sort of interesting side of it. So without further ado, we'll let David get started.
We are presently looking at the rear of the cylinder block. As you will be well aware, the P2 is a 3-cylinder engine, and what we're looking at here are the stuffing boxes where the piston rods come through, and in this hole here are the packings which prevent steam leaking out of the piston rod when it's moving backwards and forwards. Above that, this is a slide bar support, and then above that we have the bits that distinguish this locomotive from most steam locomotives around today. These are the housings for the poppet valves. This, the smaller one, is the inlet valve, and the larger one here is the exhaust valve. The steam for the inlet comes in through a cast steel steam port here, which is something that William Cook Cast Product at Sheffield made for us, and has subsequently been machined up and welded onto the next of the structure. The exhaust comes out of the ports here, which go down to the cylinders, through the valve, and then goes backwards into another series of ports which are between the frames inside the cylinder assembly to come out at the blast pipe. Now, as we move across to the middle, we have a repeat performance with another stuffing box here, piston rod, slide bar mounting. The difference this time is that we have moved the valves from being above the cylinder, because if they had been, they'd have ended up in the smoke box, down to one side here. But the relationship between inlet, exhaust and cylinder is geometrically the same as it is on the outside cylinder, except that it's tipped over. Again, we have a cast steel steam port feeding from each end, at each end. These cast steel steam ports represent a major departure from the original design, which was flawed by having the ports feeding these cylinders built in to the centre casting, and where in some cases they were separated from exhaust only by a single thickness of cast iron. This had the downside of, when the engine was working hard, the incoming steam was superheating the outgoing exhaust up to 100 degrees Fahrenheit when they measured this on the Vitry plant. This is, of course, is very undesirable because that's wasted energy. It also had the other drawback that the extra energy in the exhaust made the blast so fierce that it tended to lift the fire off the grate. What we've done in the redesign is to keep the inlet steam separate from the frames and the exhaust as much as possible so that we don't get this heat transfer going on. The final thing I will point to here is this. This comes out of the exhaust ports inside and is the feed for exhaust steam to the exhaust steam injector at the back of the engine.
Right, I'm just going to scroll on just for a few moments. There we go.
One more thing we'll look at before we move round to the front. Effectively identical. This is a full-sized 3D printed model of an inlet valve. It's what is known as a double beat valve. So there are actually two seats, one there and one here, which make contact with the seats inside the valve chamber to seal it when it's closed. Now, this in principle is like a car valve, but they are only single seat or beat valves. The reason why we need two in this design is that the volumes of steam are much larger than the corresponding volumes of exhaust or inlet gas that you would find on a car type engine. So in order to give greater capacity, as soon as this valve opens, steam can pass round here into the cylinder and through the middle. This makes the effective area of the valve when it is open much bigger than a normal car valve would be. And this locates inside the steam valve port and steam chest here. I'm just offering up to roughly where it is at the moment. There will ultimately be cast iron seats pressed into these places to form the seal with the valve. Now the valve itself will have a spring on the outside here between it and the cover to keep it shut, and there will be a spindle in the hole here which extends through a seal and another valve seat into the middle area of the cylinder block.
Okay, and I'll just scroll on.
One thing we have to do with
cut out 2 minutes. Here we go.
Valves, inside cylinder steam valves. The valve and valve spindle are mounted on what is effectively a combined inner seat and valve guide, such that the spindle sticks a little way out of this housing here when fully installed. We then have a cam box which sits in here, which has a total of 6 tappets sticking out of it, each of which comes into contact with one of these spindles. And the cam, as it goes round, pushes the tappet in and out to open the valve when you require it. Now, to add to the complexity, we have a problem on this, that having moved the valves for the middle cylinder over to this side of the block, the drive for the inlet valve for the middle cylinder is still on the other side of the engine. So to overcome this, we have designed a set of rocker shafts and rockers which will come down to here, where you will see where the valves come out for the inside cylinder inlet valve. And the rockers will pass across the top of the cylinder there, through the gap you can see, so that the rocker on the other side corresponds to the inlet valve cams, which are attached to the cam box on the other side. The cam boxes themselves will be mounted on runners, which will be welded into here once all the rest of the work has been done, and they're designed so that there's just a couple of bolts hold each cam box in, and for maintenance purposes you undo the bolts with their catches and then just slide the whole cam box out and work on it on a bench, because obviously there is not a lot of room inside here to be able to take the cam box apart.
I think that's about it. So there we go. Right, okay. back to me again for the last bit. So, electricery. So, on a different subject. The electrical system on the locomotive will be based on the successful electrical system on the A1 locomotive. We reckon there was about 3 miles of wiring in total on the locomotive. So, somewhat moved on from the days of a car battery and 2 crocodile clips. There's dual redundant power supplies. You can switch between one and the other for reliability. And the power supply comes from a steam turbine and axle-driven generators. And the clever little box of tricks, it senses the input from both and decides which one it wants as the most powerful. And that basically keeps the batteries charged, and the batteries actually provide the power for the various things. The most important thing that we need power for is modern signalling systems. Involve increasingly amount of electrical and indeed electronic equipment in the cabs of locomotive, so we need a reliable power source for those. Talking of which, here is the signalling, known as command, control and signalling in the industry these days. So AWS, for those that know the railway, is the original British rail system fitted from the 1950s onwards. TPWS, Train Protection Warning System, was fitted from the early 2000s onwards. And we've now got GSMR, digital radio, and OTMR is data recorders. It carries a black box. Even though it's painted orange, it is actually a black box. But we're now faced with the new European Rail Traffic Management System. Despite the fact we've now left Europe, supposedly, it's available. And it is the next sort of generation of signalling systems that's going to be fitted as part of a Network Rail sort of major modification over the next generation. And steam locomotives, because they're already on the main line and the changes being imposed on them, Network Rail fund the project to make sure they can retain that compatibility. It's not just, they're not legally allowed to sort of marginalise any types of locomotives on that basis. So there is now a Pathfinder project which is looking to fit this equipment initially to Tornado. It's currently being fitted, well, as I speak, shall we say, to the locomotive, and will be tested early in the new year and will be fitted from new to Prince of Wales. The power generation, Tornado used second-hand turbo generators that were being used, particularly our colleagues in Germany, who we'll come on to in a moment for the boiler design. They were also using those. Much more common to have electrical power on locos in Europe than in the UK. And steam power turbo generators are quite sort of common, but they're older and getting older and older. So this is about trying to beat obsolescence and come up with a new design of generator using quite a bit of modern automotive technology, truck generators, roughly the same size and power, but just sort of adapted for steam being the actual power to create the energy. And we're doing a similar thing with the axle-driven alternator, or ADA, as she's affectionately become known. Again, we were using old British Rail ones, and you know, the spare parts are becoming more and more difficult to obtain. So this is a new design that the A1 Trust has done, and there's interest from the Network Rail project team to use this for the other steam locomotives that will need to provide additional electrical power for the new signalling system. Other manufacturing progress then, just to sort of summary on everything else. We've still got to build the basic locomotive, so there's final work on the mainframes, more or less done now. The new boiler, coupling rods, tender manufacture, and the various detail parts to keep pace with the project that David referred to earlier. So the work on the frames are held together by a series of stays, large components. The originals were cast. Again, we're looking for, we've used fabricated design, but because of some revised equipment we need, particularly the air pumps for the air supply for the brakes, they're being redesigned. So you can see there this equivalent stay on the right-hand side there is the new version of the old one. So if we've changed something, we have to prove it's going to be at least as good as the original. And again, this is where the CAD comes in so useful, because you can get an FEA bolt on to the 3D CAD and tweak the arrangement of the grid, and then you can start sort of doing the usual stress analysis. So we've done that with the new frame stay designs to prove they're going to be as good and not give any problems. So that's been done. And there's just it's a little bit of a few years ago now, but that was a final stay fitted in between the frames there. So this is the stay here, keeping the two main frame plates apart. And since then, all this pipe and tubing has been installed. You can see how busy that is. So that's steam, that's electrical power, oil, etc., as David was saying. Actually, most of that piping will come off again to be painted before it's finally bolted on for keeps. The boiler then, this is a major area where we're actually able to use the same as we did for Tornado. The boiler has actually been designed around the Tornado boiler. It's the same at the back. At the front, the original P2s had a slightly longer boiler barrel, but you don't tend to get as much sort of useful heat energy out of the front as you do the back. So we've actually redesigned it so to use the same template of boiler, same size. They then become interchangeable. One of the advantages of that is smaller boiler barrel, larger smoke box, and you can then even out the sort of vacuum effect on the exhaust. So that's a bit of a benefit. Increased steam pressure. The originals ran at 220. This boiler runs at 250 psi, more than compensates for the loss of space, water space. So that is what is happening. And here is one of the new boilers under construction. We've actually signed a contract for 2 boilers to this diagram, thanks to a generous legacy. And that means we'll now have 2 locomotives with 3 boilers, because it's the boiler that is usually the big ticket item that keeps the locomotive off the main line. But effectively, we'll get to a stable state where we've got one on the shelf, literally overhauled. So either locomotive comes in and it's a matter of a month or so to swap everything round and it's back out again, rather than being off the main line for a year, 18 months or however long it takes. So that is what's been done. It's all welded technology. So what we're calling the diagram 118A boiler is a welded design of the original riveted equivalent using modern welding technology. The Germans are particularly good at this. So this is built at the Deutsche Bahn Meiningen Works in Thuringia Forest. And we basically went back to them, having been so successful with the one for Tornado. So that's currently work in progress. Should be arriving sometime later this year. And then coupling rod manufacturer. Just fairly straightforward. Most people do this, but actually finding forgings that will actually deal with this sort of size of material in the UK is getting harder. But this is appropriately named Robert Stevenson Engineering. How about that? And they're based in Manchester, and they've made the rods for us on this occasion. And then they are all fitted, and you saw in the first video the test that they will go around smoothly. So they're pretty much fitted first time, very little adjustment needed, and no binding. So the rods are done, and the other, of course, it's not got the valve gear in the same way. It's only got the connecting rods. They're also done as well. So they're all available. And as it says, this doesn't happen without people. Because of the amount of engineering work required, the project has been able to actually recruit and employ people. So Daniela, pictured here, was David's design assistant for much of the design work, which is largely complete now. As it happens, she's now gone independent, set herself up in the Darlington area, but still available to us if required. And we've also got an electrical design engineer working on some of the projects I've been talking about, and the apprentice machinist. It's nice to be able to bring the young people on as well. You get lots of ticks in boxes for doing things like that from the funding authorities, as you know. Another aspect here, this is more sort of partly where I come in, is that we've been trying throughout to sort of keep the industry on board. I mean, the British sort of mainline railway industry. We don't want to suddenly sort of present them with this at the end and say, can we run our locomotive on your tracks? We try and do that beforehand. So we've spoken to Network Rail and the operators. And this is the RSSB, Rolling Stock Standards Committee, fine body of men. RSSB sits at the centre of the industry. Safety and standards is the S and S. So their sort of blessing or support is also useful. So here they are, obviously seeing the thing in person, so it isn't a surprise to them when it comes to the day, as it were. It was also, didn't go unnoticed, that somebody else was building a Prince of Wales, rather bigger and more expensive than ours, but yes, the second of the new carriers was named Prince of Wales, so we went in search of the people in the Ministry of Defence, and we've eventually set up what they've called a bond of friendship with Prince of Wales. So we've had several events where we visited them and they visited us. And this picture here is actually the first, the new carrier, Prince of Wales' first public engagement, which was actually Liverpool, which I understand is its adopted port or city. And just before lockdown, actually, we just managed to get down there, and we had a collection of us on the hangar deck there as part of a STEM event at the school. So that was quite nice. And then finally, to end on, well, another exciting note, back to Darlington Borough Council. It doesn't need me to explain too much to an audience in this part of the world that 2025 is going to be a big celebration year. As already referred to, the 200th anniversary of the original Stockton and Darlington Railway, the world's first public railway, and the manufacturing location at Darlington that we inhabit, of course, is athwart the original Stockton and Darlington main line, so we're right in the thick of things. We actually currently occupy this building here, which we affectionately call Darlington Locomotive Works. We've been in there since the mid-1990s with the support of Darlington Borough Council. It does have one major disadvantage: it's not connected to the railway at all. So it's a low loader in and out every time. Anyway, discussions with Darlington Borough Council on the whole theme of 2025, what are they going to do? We were involved in those conversations, you know, for, well, quite a few years leading up to now. And basically, to cut a long story short, Darlington Locomotive Works 2, DLW2, is being built by Darlington Borough Council as part of the Heritage Quarter that's being set up around the old Darlington Locomotive Works. So this sort of groundworks here, this is becoming Darlington Locomotive Works 2. And for those of you that know your railway around, this is Darlington North Road Station, where the museum is, and there's a little loop of track here and a handy spur of track that can be directly connected. So this will be a rail connected facility. So that's really exciting news. That's all happening at the moment. There's the artist's impression of it. So this is the new DLW2 works, a 2-road shed, each road capable of taking 2 locomotives. And this at the back here will be the office block. We do occupy an office at the old building, but it's very old and drafty, so this will be a purpose facility. This will be a footbridge that crosses the line, so visitors can visit the original museum in the station here, which is being refurbished, and then go across the line and straight into our works for a viewing platform to see what's going on in there. So that's the arrangement. And here it is, under construction. This is a drone picture from at the end of last year. You can see work quite advanced there. If you've been past that site at Darlington, you'll have seen or wonder what the works was going on there. This is what it is. And there we are. This is the inside. This is the office building and the balcony. Pretty much sort of weatherproof now. And this is the pit road. Inside the shed, there'll be a plain road and a pit road. So we'll be able to obviously to get the locomotive over the pit and work on the underneath as well as the inside. So it'll be a construction facility for new locomotives, because we're hoping not to stop at the P2. And it'll be a maintenance facility for the existing locomotives. So we should hopefully be moving across the road sometime in the late spring, early summer, we hope. And so the locomotive, the P2, will have to be low loaded out across the road and put back on the rails, and then hopefully when it's finished it'll steam straight out onto the network or whatever. So I think that is the final slide, actually. Yes, there we go. So thank you for your attention and interest, and any questions, happy to take them.
Well, that was fascinating, absolutely fascinating, Graham. And you know, I'm amazed at the way that you can handle the new technology and improve on something to that degree, especially the fabrication, if I may say so. Yeah. Absolutely wonderful. Right, there we are. Questions, please. Could you please state who you are and where you're from, which group you're with? So, could we have any questions? Or are you all frozen?
You're all you're dumbfounded.
Totally dumbfounded.
I won't need that. That's for those on YouTube.
Thanks, Margaret.
Malcolm Atkinson, NEIMME. I'm not a train buff in any sense. I love to see the old steam trains, but it just seems to me that the first question is, why are we building this, right? I mean, given the fact that we are at the point of decarbonising everything and this, that and the other, it seems to me that you suggested that you were making two. And I wondered if that was because of a commercial enterprise that you've got on. I mean, clearly there are still steam trains which are running and making money, one assumes. So really that's my question. I mean, fascinating, and you know, I applaud you for all of the advances that you've made and you know, the engineering that goes into it. But as I said, my question was really why?
Why? It's an easy question to answer, but it's also a hard question to answer. I mean, the easy question is because we love doing it. They don't make money, actually. Tornado doesn't make money. There are still covenanters who give money to Tornado to keep the funding model working. So they're not money making on their own right. People do it for the love and the passion of it. They really do. But what I would say is you kind of look at the history over 50 years in the sense that British Rail stopped using steam locomotives in 1968. There was then a 3 or 4 year hiatus, and the modern sort of history of steam locomotives, preserved steam locomotives running in the main line started in 1972. And at that, the two things then, in 1972 it was existing locomotives just fired up again and used, and it was mainly railway enthusiasts that went on those trips. And what's happened over the last 50 years is that sort of has changed. There's less railway enthusiast travel, and there's more people having, it's part of the leisure industry is what I'm trying to say. They go and enjoy a day out, and you're competing with Alton Towers, a stately home, or whatever. And the steam locomotive is the icing on the cake, because you're sitting on the train in nice sort of plush surroundings. You might be getting a meal served to you. You're going to an interesting destination, and that's the package. And the steam locomotive is part of that package. And it's just become now sort of ingrained in the sort of leisure industry. If you go up to Scotland, if you go into the Highlands of Scotland, you go on the Fort William Mallet Jacobite, you go on the Harry Potter train. You know, there's people all over the hillside there looking at the train. They're not rail enthusiasts. It's just something that's kind of, you know, drawing people in, and it's part of the sort of leisure industry and the leisure offer. So that's kind of what's keeping it going. I mean, at that level, it's sustainable. But in order to fund the locomotive, there needs to be some sort of charitable money-giving arrangement behind it. And lastly is the locomotives that were first used 50 years ago were then 40, 50 years old. They're now coming up for 100 years old. They can't go on forever. So locomotives like Prince of Wales and Tornado and, you know, others to follow, hopefully we'll sort of carry the torch forward well into the 21st century, and you know, it'll be someone else's problem in 30, 40 years' time in terms of the next generation. So that's the best answer I can give. It's a good question. There you go.
Another question, David?
Hi, David Mobbs from the Institute of Corrosion. Could they be used commercially?
No, they couldn't be used commercially, and I was very sort of gratified at the introduction I got in at the start. I mean, in my sort of professional career, I mean, I am you might not surprise to know, the heritage advisor for RSSB for mainline running. And the thing is, these things are, there's some tautology here. They're regarded as non-mainline locomotives running on the main line because they don't comply with current standards. They can't do. I mean, a silly one, the front end should be painted yellow, you know, and the driver, where he's sitting in the cab, completely breaks all the sort of rules about visibility and forward sighting. So no, they can't be. They run under a special set of rules on a limited basis of exposure to the network. So if you were to do a commercial thing, I mean, it's almost inconceivable. You'd have to completely redesign the steam locomotive with a cab at the front and, I don't know, some sort of electro-turbo generation of power, or, I don't know, it would look very, very radical. So, sadly, no.
Any more questions? Oh, Malcolm again.
There we go.
Sorry, you've confused me. You're saying it cannot run commercially,
Yeah.
but yet presumably there are steam trains that are running commercially still on the main line.
No. Well, commercially, I think what was meant by the question is that they were running commercially would mean that they're at the head of the 1025 from Newcastle to King's Cross, you know, every day and back. I mean, that would be regarded as normal mainline operation. Yes, there's a commercial thing around how you put together a heritage charter train, but it itself is not a commercial operation. It's a charter, one-off charter operation, which is a completely different thing.
So the heritage charter runs on the main line,
Yeah,
right?
or under a special set of rules,
Right.
basically. Yeah,
Okay.
yeah.
And clearly can it get up to the speed of 100
No,
mile an hour or whatever?
No. To be honest, they're a liability on the East Coast Main Line. The reason we ran Tornado at 100 miles an hour was to try and get a sort of 90 mile an hour case for running it. They're currently restricted to 75 miles an hour, the big locomotives, which is okay on a secondary line, but they get in the way on the East Coast Main Line. I can foresee a time when they won't run on the big trunk lines. They'll be more on the Settle Carlisle and the more scenic tourist lines.
Okay, thanks.
Hi, Bill Bell, NEIMME. Given the advances you've been making with the engineering aspects of this thing, you mentioned lots of steel and brass components and whatnot. How about aluminium, Kevlar, titanium? Anything of that nature involved, or?
No, not particularly. I think we'll use modern technology where it's beneficial to the project in terms of either ease of manufacture or ease of approval, but the idea is still to keep it looking original. Yeah. So there's only so far you can take it in certain ways, and I suppose if you were using a really revolutionary material, you then have to do a lot of sort of research and proving up front that it was as good as the original, and you weren't introducing unforeseen technical sort of faults with it. So yeah, to some extent, but there is a limit. Yeah.
I was thinking on the sort of inertia aspect of
Yes.
getting the actual thing moving
Yeah.
in the first place, you know, the weight factors.
Yeah, it's the power to weight ratio, isn't it? It's all about, of course, a steam locomotive generates its own power, so it's got to have a source of power, which is the big boiler. So I think you're at the margins in terms of what weight and sort of savings you'd gain for something like that, to be honest with you.
One final thing, the source of supply for the fuel. Yeah.
Well, we predicted this question would come up, yeah, especially given such an audience. Yes, it's. I think we're carrying on regardless. Quite frankly, I think that problem will be solved somehow or other. It's very, very difficult to say at the moment. The supply of coal was coming from, believe it or not, Russia. So the current foreign source of coal is coming from Colombia, and it's £500 a tonne. But funnily enough, a UK supply of coal in South Wales, which is due to close, has magically had its licence extended for 2 years in the last 6 months. I think, well, fancy that. So I think between that, they are experimenting with sort of biocoal and things like that, which is for smaller steam locomotives. I think that is practical. For something this size, don't know.
Well, not to put a damper on it, but we were at Ryhope pumping station, which is on the coast there, some while ago. But the guy there with the boilers, he had Colombian coal, and he said he could hardly get ahead of steam. So But interesting, the calorific value and things like that.
Yeah, at the moment, it's everything's so sort of volatile. It's quite difficult to predict how the future will settle down. But I'm sure I have confidence in the industry that it will sort itself out, because it's not just you're talking about RIOP. I mean, it's not just mainline steam locomotive. You've got the traction engine fraternity,
Yes.
people that use boilers in ships and what have you. So there's quite a community that has a vested interest in it. So I'm sure there'll be a solution
Thank you.
for the future.
Thank you.
Simon Harris, Institution of Civil Engineers. Could you talk a bit about the tender? I mean, is it similar to the Tornado?
It's exactly the same as Tornado. Yes,
Ah,
yes. It's
right.
it's exactly it's
Because it's the same boiler, so you've got
yeah, it's the same tender. Yeah, they ran with very similar, virtually identical tenders. It's a 4-axle tender, which spreads the load out a little bit better. It's modified in terms of the proportion of coal versus water it carries. The more volume of water you carry, the less volume of coal you carry. And what we've done is maximise the water and reduce the coal, because it's the water that's the defining factor. Tornado does about, oh crikey, you've put me on the spot here, with a full tender of about 6,000 gallons, that's good for about 150 miles, 150 miles. You know, you'll do before you need to start thinking about filling up with water. And the trouble is, British Rail had water troughs and water columns, and you know, locomotives picked up water on the move. Can't do that now. You've got to go into a loop offside the main line. Someone's got to turn up with a sort of fire tender pumping arrangement, and you fill the tender up again. So it's all about maximising water capacity and making the use of the water as efficient as possible. One of the things an all-welded boiler will do, and teaching Graham to suck eggs here, it either leaks or it doesn't leak. You know, and if it's well maintained, it won't lose any water or steam. So it's quite economical. We get good sort of mile per volume use with it as well. But yeah, it's all about water versus coal capacity.
Okay, thanks. And are you required to sort of satisfy emission controls from your chimney?
Well, if you mean Network Rail, who own the tracks, in terms of our ability to run on them, there's quite a bit in that, in terms of anything from clearances to track forces, signal sighting. You know, there's quite a bit to you know, demonstrate that you do there and satisfy. And each trip almost needs planned in terms of where you're going. You know, what time you're going to be there, how long's the train.
Yeah. And what about air quality? That's sort of
not really.
No one's bothered.
No. Well, I think it's so small in terms of the contribution of this to the nation's carbon footprint. It's minuscule. It's minuscule, and the economic benefit for the tourism industry is kind of a bit of the balance, really. So, yeah.
Thank you.
More questions?
Derek Newton at NEIMME. The modifications you've made to the engine, I know a lot of it's to do with reliability, etc. Will you be getting more power from it, and could that increase the speed of it, or are you just looking for reliability? There's these two factors. It's the power should be the same. Right. It's reliability and acceptability. So the reliability is important. You don't want the thing breaking down or forever back in the workshop. But the acceptability is actually about getting the yes at the end of the day to be able to actually run it at all. And with the things like broken axles and track spread, those are the things, as I've explained, we've had to sort of deal with. So yes, it's about those factors. It's not about increasing the performance. It's about recreating the same performance and creating it reliably. So, I mean, the thing will be the most powerful steam locomotive out there, quite simply. It'll outhaul anything on paper. We just need to make it do that in reality without it breaking down all the time. Thank you. It's been a fascinating talk.
Yeah.
And I think everybody's enjoyed it as well.
Thank you.
Anyone else? Got room for one more? Oh, got room for two more then.
Two more.
Erwin Thompson, NEIMME. A very simple question. You mentioned that you were increasing the size of something by 3/8 of an inch.
Yes.
So is this non-metric?
That's not a simple question.
The question's simple.
The question's simple now. But believe it or not, right, this is to do with the roller bearings. The first locomotive Tornado was fitted with roller bearings, and that's to a design from British Rail days in the 1950s. 5 of the original A1 locomotives that Tornado is were fitted with Timken roller bearings in the 1950s. And it was actually done, on paper it was to improve the reliability of the locos. It was actually in practice a test bed for Timken, knowing that the diesel electric fleet coming along would all need roller bearings because they were faster and obviously wanted to be sort of maintained at low maintenance. So that design of roller bearing is still on Timken's shelf 50 years on. So it's about creating the axle seat such that it fits a common component rather than a specialised component. So that's kind of what it was about. So it probably is an imperial size originally. You're going to put me on the spot a bit, remembering what the actual size is. I think it might be, it's gone up to 10 inches from 9 5/8 or something. But I think that one is an imperial size. But yeah, metric versus imperial crops up all over the place because steel plate you only get in metric sizes now. So you have to kind of work out, well, what's the equivalent, the nearest. And then you've got to adjust everything slightly to fit, which was more of a problem with Tornado than this one because the 3D CAD copes with that. But yes, it does raise its ugly head. David Elliott refers to them as Christian units and pagan units, and I won't have to tell you which is which.
Well, David Morgs, we've got time for one more question, I think.
Ever so quickly, could it not run on briquettes, that have high calorific value?
I think that's all for the future. Yeah, but there may well be a solution somewhere in the mix of all that, but don't know at the moment.
Right, well, thank you very much for answering these questions. There's some quite technical ones there. I'm sure there's a lot more questions, and maybe if we can...
I've got a remote person.
Oh, right, lovely.
Sorry, remote. Yeah, I wondered if you might have a remote question.
Yes.
Yeah.
Thank you. I'll just give the comments first. So, N. Draychick, an excellent presentation. Thank you so much. Paul Hardman, who's known to other council members. Hello, everyone, and greetings from a very sunny Houston. Right. Fascinating, and good luck with the final assembly. Look forward to seeing it under steam. And then a question from Graham Russell. In terms of P2 certification, are there any significant challenge areas of the build outstanding compared to the Tornado's certification?
I would say the short answer to that question is no, because I think the challenges, there was really two challenges. One was the pony truck and the ride of the vehicle, which we've comprehensively proved using industry methods. So it's almost beyond question that as it were. And the other was a crank axle braking. Those are the two things that would have stopped it going on the main line from an approval point of view. The rest of it is the same as Tornado in terms of the relative level of challenge. And we actually went to, it's the rail regulator who says yes or no ultimately. And we went to the rail regulator with this scheme, 2010, to sound them out. And the answer, he's a lovely gentleman, and it was a wonderful answer, encapsulating one sentence. It says, you've done the hard part. It says, you proved it was possible with Tornado. So provided we do the same, to the same level, it shouldn't be, there shouldn't be any nasty surprises for us at the 11th hour.
Right, well, thank you very much. And, okay. There's been so much there that my mind's absolutely full of it. So I'm going to call now on David Granger to give a vote of thanks on behalf of everyone.
Okay. Can you hear me? Yes. Mr. Past President, ladies and gentlemen, well, what a fascinating talk this evening. I mean, I must admit that a lot of the engineering sort of went bit over my head, but that's beside the point. It's absolutely fascinating, and I've made a few notes. Anyway, it's a boy's own dream, of course, to drive a locomotive, a steam locomotive, and I suppose we've all had those dreams, but to actually go about building one is the whole, state-of-the-art difference. It's actually incredible achievement, and I think you can be justly proud of yourselves for doing it. I mean, okay, it isn't quite on the rails yet, but let's hope by 2025, for the 200th anniversary, the Stockton Darlington, it will be, and I'm sure we'll all be very interested in seeing it in steam. I mean, it'd be absolutely incredible. I mean, I did see the Flying Scotsman in steam on the Settle Carlisle Railway many years ago, and that was quite a thing. Driving on the road, and all these people, in lay-bys and everything, oh, what the hell are they doing? And then suddenly, round the corner came this apparition, absolutely incredible. So that's fantastic. But without going into lots and lots of detail, repeating what you say, which is absolutely incredible, what really struck me was David Elliott. Here's this guy who was talking about this very technical thing about what was it, the cylinders.
Cylinders and valves, yeah.
And there he was in a suit and tie. Absolutely dapper. I mean, absolutely incredible. Giving us a lecture there and then. I thought it was absolutely brilliant. And I'm sure that ethos, shall we say, goes to the whole of your organisation. So, without more ado, thank you very much for a most entertaining evening. And please, shall we, in the usual manner, give our appreciation. Thank you very much. And sorry, can I just say another thing? There's been, in the context of all this media frenzy about royalty, and we got the Prince of Wales, and so on, have you actually got a spare?
Very good.
Well, we do have royal blessing for the name. I forgot to mention before, I brought some leaflets with me, so they're on the table outside as well as here, so if you'd like to take one, then that's the best sort of reward for this evening I could have. Thank you.
And also, it would be very, very nice if on this opening day in Darlington that a few members of the Institute were invited along. But that's a plug.
Keep your ear to the ground.
We shall indeed, Greg, we shall indeed. Right, well, there we are. All I can say now is mention the next meeting we're having, which will, as I said before, be Dr. Charlotte Adams. She's quite an authority on this mine water heat reclamation schemes. So she'll be talking to us on Thursday, the 16th of February, and I hope you all come along for that one too, because I'm sure you'll enjoy it just as much as you have this evening, and my heavens, we've enjoyed it this evening. One last little thing to say is, as you leave, if you haven't already done so, could you really sign the book and the IOM3 forms, because there is something involved in it for us. And with that, can I say thank you very much for all?
I'd just like to say that the NEIMME are going to give a contribution, a donation to the project. If anybody wants to kind of join in with us, kind of get me in contact with me, please.